Hi. So, thank you. And so, uh, in my last video, that was the first part of this semiconductor physics simulation. So, we're actually simulating a simple diode here. So, uh, maybe in our after some videos we'll start solar cell simulation. So that is actually different on semiconductor physics. So uh, before entering the complex geometry or complex thing, we are actually trying to simulate something um, that is much easier. So you can understand the basic physics of semiconductor, how the semiconductor physics actually works in COMSOL. And that's how you will understand the simulation of your solar cell or something else. So some things actually that's rely on semiconductors physics. So that's the thing. So that's our actually goal. So we want to learn the whole semiconductor physics from this playlist, and um, then we'll learn complex things like solar cell or any other um, simulation. You can mention his device you want to learn. Maybe I can um, upload on this topic. So thank you. Okay. So if you just like our videos, you can like, subscribe, and share our video. That's actually sometimes helps us. Okay. Without further discussion, so in our first video, maybe we start from 1D, then we work on 2D, and then we simulate 3D actually. So in our first video, maybe was that um, 3D simulation is quite complex, right? So the complex part is actually mesh in 3D simulation. Uh, so here for 3D simulation, you know that you have to select user control mesh and sweep mesh. Without this kind of mesh, you cannot actually simulate 3D semiconductor device. Oh, okay. So that's the thing. So, so easiest way is simulate 2D or simulate 1D. 1D is far for easiest. So, right. So today, okay, as I mentioned now my last video, in my last video, maybe we just work on this graph, right? So carrier concentration curve. So I mentioned that we will recreate this curve, the current versus voltage curve of diode. So let's go. So in our last video, we didn't apply any what can I say, any external voltage, right? In our device. So you can see that, okay, in our on D simulation. So this is our 1D part, right? So we can hide 2D, 3D, okay. So in our 1D part, okay, I can mention if you are watching from this part, we are mentioning that study one was for 1D simulation, study two was for 2D, and study three was for 3D simulation. So, okay, thank you. So this part is for 1D simulation. So here you can see that we dope this part as P type, right? Okay, as P type doping, and this part as N type doping, right? So, okay, here the doping concentration is this kind of thing. So, we dope this two part, but we didn't apply any voltage, external voltage, right? So, as our basic thing that we can apply forward voltage or backward voltage in diode. So, if we apply forward voltage, then we will get this kind of curve, right? From 0 voltage to some kind of. So this is semiconductor, sorry, silicon semiconductor, right? So for silicon semiconductor, the breakdown voltage is kind of what, 0.7 voltage, right? So maybe 0.7 voltage. So sorry, threshold voltage is 0.7 voltage. Sorry. So we want to recreate this figure. So for for that for that we have to apply some voltage from we have to apply some forward voltage, right? So to apply some forward voltage, we have to define something. Okay, sorry. We have to define from boundaries. We have to define some voltage from here and here. So we have to define some from boundary. So from boundary, we have to define metal contact. So yeah, so from metal contact, we can select this boundary. Okay. So I have to mention again, this is the p-type part, right? So you actually know, I think you know that this is the basic thing of semiconductor, so of diode actually. So I think you know that um, for in the p-type for forward bias voltage, you have to apply positive voltage in p-type p side and okay, and we have to apply negative voltage or zero voltage in n side. Okay, so that's the thing. So in here you can actually um, put some positive voltage. So we want to actually vary the voltage of this side. So that's why we want to apply V naught, V0. Okay, V naught. So just copy this thing. And in parameters, okay. So first time we are defining some parameters. So this is the global definition actually. So here, if you define any parameters, that will work for all the things for component 2, component 3, or component on. So here we are placing V naught and we are placing just uh, 0 voltage. Okay. So that's 0 voltage. We are defining 0 voltage. Okay. So V naught is initial value is 0 voltage. Then we will vary it. Okay. Don't worry about it. So we apply here some voltage. We are applying here some voltage, and we have to also apply here. So we have to. Okay. So you can just duplicate this metal contact. Okay. So metal contact, you can rename it. Okay, metal contact beside metal contact or right. So wait, so we may just duplicate this. So it's selected. So deselect it, and you have to select this uh, boundary, and so we cannot apply any voltage here, right? So you cannot apply any voltage current or any other things. So the voltage here is zero. Okay, you don't have to think anything about it. Okay, think that's all. So mesh, as we just did our mesh before, so we don't need to think about anything here. So thank you. So mesh is good. Okay. So if you don't know how we mesh this thing, you can also first video, then you can come back here. So if you just follow the mm, sequence of the video, then you will actually understand the semiconductor physics, entire semiconductor physics actually. So I recommend you to first video. If you don't want to just watch this first video, then I'm mentioning that um, here we just apply user control mesh. If you just apply user control mesh, and you can just build it, or you can define Sorry. You can apply just physics control mesh, then it's quite easy. And if you apply user control mesh, then you have to define by yourself. So you can apply here for 1D, it's not a big deal actually. So, okay, in the mesh and physics, we don't have to do anything more. So in study one, okay, we know that is okay. So as you can see in the section physics and variable section. So if in your case maybe it's hidden, but you have to just okay. So you have to select only component on rights because we want to simulate just one department, right? So that's the thing. So and another thing you have to do here, you have to apply parametric sweep. Okay, parametric sweep, it will just sweep the voltage value. Okay, the yellow voltage. Okay, so if you just click here, we can just define if you do have some other parameters value. Okay, so you have to just click here and you have to select which parameter you have to select. You want to select. So maybe you do have some other parameters like a the value of a is something a 0 or something else. Maybe it's uh top of b naught, then it will not appear instantly. So you can select A or you can select B. Okay. So we are actually on to vary V naught. So we are selecting V naught. So then you have to vary the value. So here the voltage is V, so it's okay. So we have to just put the value of. So you can just select a step or numbers of value or logarithmic log, logarithmic. Okay, thank you. So we just want to select a step. So it will start from 0 voltage and the step size will be point 0, maybe point, okay, just point 1 voltage and can we can run it from 0 voltage to 1.5 voltage. So just replace it. That's all. You don't have to put anything else and just just compute it. Okay? And wait until uh something like that. So it will take close time. Okay, thank you. So and the energy level actually what they did, they actually plot all the values of energy values for all the uh, parametric parameter selection. So there they select all the parameter selection. You can just select from list so that you can vary. For example, just you select point A, right? So then you can plot it, then you can see that just single energy level are showing here for relevant for production better. Okay, okay. Then you have to see the carrier concentration as we seen it before. It doesn't sense loss, yeah, but you can change it. Yeah, for 0.87 voltage, you can see that uh, it sense loss, right? Because the we just mm, made it constant, right? So then electric potential. Okay. That's the thing. It's just like before uh dopant concentration. It's also just like before. So here we don't have to do anything more. So we have paused. Okay. What do we actually want to know? We actually want to know the graph of voltage versus current, right? So on the result, you have to click right click, then you'll get one plot graph. Okay. on the plot book. So just scroll down here. Okay. Then right click here and global. So from global we have to put the expression. So as you know, we just get expression from here. So for component one, right, we simulate component one and terminal. Okay. So here you can see the terminal current, terminal current of terminal current for terminal 1, terminal current for terminal 2, average current density 1 and 2, and terminal voltage. Okay, so what do we actually want to know? So this is terminal 1, right? So we just replace 1 with P, and this is terminal 2, right? So terminal we apply voltage in terminal 1, and terminal 2 was grounded, so kind of, right? So okay, so we have to just we want to plot the current terminal 1 with respect to voltage, right? So you have to define, okay, it's automatically select the parametric value, but you can change it by expression. So the expression is terminal voltage. Or okay, so we apply the voltage in terminal 1. So, sorry, check solution. Let me check it. Just oh, oh, simple. Let me check it again. Okay, it's the P terminal, right? So apply voltage here. I not okay. And you zero zero voltage, right? So it's okay. Pins open. It's intake. It's okay, right? It's intake. Okay. We have to apply positive voltage in P type. It's okay. And quite simple. Being bent. So it now plus voltage from 0 to 1.5, and it's also running 0 to 1.5, but no current cannot happen actually. No what's happening, but okay, maybe we have to apply more voltage. Okay, then so let again. I don't know. The voltage is so high. Oh, sorry. The, uh, so put this 5 put this gas. Let me check just one second. Just wait. See a few seconds. See. Everything will fine. Everything's fine. Everything's fine. Good. Yeah. I would identify the problem actually. It's okay, right? It's terminal one. So okay. And the contact. It's okay. It's not 10 actually, but I put it. Oh, I'm sorry. I'm sorry. Sorry. You cannot actually uh, run by parametric system. I'm so sorry about it. I did it wrong. So you cannot run parametric sync for semiconductor. Oh, what the hell, man. I'm so sorry. Actually, I did it wrong. I didn't look that it's semiconductor equation. It's just run semiconductor equation. It's not simulating our voltage actually. Okay, I'm so sorry. Uh, okay, we have to add studies. Okay. To add studies. So we have to add stationary study. I'm so sorry. We have to add stationary study. So uh, in the study four, we under the study four, it's actually 1D. Yeah? Study four, so 1D. Right. So under semiconductor, okay, semiconductor, but we have to run just 1D, right? Okay, thank you. So here you can see that study expression. So oh sorry, external extension. So under external extension, you do have auxiliary sweep. So for auxiliary sweep, you can just sweep the as we just sweep with parametric sweep. You can sweep it from auxiliary sweep. Okay, so you have to select V naught, and as we did it before, we have you can do it okay from 0 voltage step point to 1 voltage, and it will stop and 1.5 volts. Very less. It's voltage. Thank you. So yeah, so run it. Oh, I'm so sorry about first. So that was not actually station study. That was semiconductor equilibrium study. That just ran the semiconductor equilibrium. Just run the initial condition of the equation. It doesn't apply any voltage. So now it's actually working. So as you can see, it's provides some other values under for under under study 1D, study 1D, solution 4. Okay, so as I mentioned before, you can do it by selecting from list. Okay, you can select point 4 and you can plot it. So it's okay. Well, so carrier concentration, you can see that for different voltage, the carrier concentration actually changed. Okay, so electric potential, okay, it will also sense because of the sense of voltage and net dopant concentration. Okay, but we want to do this, so it's not this. We can just take it down here. Okay, so what you have to do, you have to select study one to on the right. Okay, solution for you can select anything, oh, any of these three. Okay, now you can see the curve. Okay, or desired curve. So I'm so sorry about my first word. Okay, so the current actually start from here, right? 0.8. So for this silicon, maybe because of doping, for here the threshold voltage was zero point 0.7 voltage, right? But mm, because of doping concentration, it makes sense. Okay, so uh, by varying the doping concentration, you can sense the threshold voltage actually. So yeah, you can see that the threshold voltage is maybe 0.8. So okay, okay. You can see in 0.6 the current is zero. So it's actually you can see that very minor current you are aware of observing it after zero point 0.6. Then 0.7 or 0.7 it does have some current. Right? And it will be using so that's the thing. Okay, thank you. I'm so sorry about my first part, but okay. And you can just simulate it in for the case of 2D as well as uh, by doing the same thing. So from boundary, you have to select metal contact and okay, so this one may be P type, right? So let me check. So this one actually P. So metal contact here. So you have to select V not, right? Okay, everything's fine. So duplicate it. Uh, duplicate, deselect, select 0, right? And in the study, you have to select another study, right? So that is study, stationary, okay? So 5 equals 2D. So in a stationary, you have to select this one and this one. And auxiliary, under auxiliary shape, you have to save V naught from 0, step 0.1, and it will stop 1.5. That's it. Okay, just simulate it. So if you think, um, okay, so maybe we'll after the simulation we'll stop our video. In our next video we'll see how the reverse bias work and yeah, that's the thing. We'll see in our next video how reverse bias work. Because this video already maybe uh, it's video 30 minutes plus. Yeah. So, let's see what's going on here. Sometimes inventory. Maybe your laptop is so fast, but it is so slow. It's the same thing, sorry. For the 1D and for the 2D, both are same. There is no big difference. So after the simulation, you can see that. This is good. Okay. Okay. So this is electron concentration. This is hole concentration, electric potential, net doping concentration. But what do you want? We want current versus potential, right? So duplicate it. So after duplicating it, you have to select which one you have to select. Study 2D, right? So, but uh, you cannot select semi one, right? You have to select from component 2, right? So terminal component 2, semi 2, right? So this one. So the same actually, right? Okay. Thank you for joining us. And okay, welcome. Welcome actually. Thank you. So see you, Baba. We'll see. Uh, let's save it. Maybe. Sorry, I will upload the next video with you um, tomorrow. So, and wait until the video. If you okay, let me clear it. If you want any other video, any topic, you can mention in the comment box. I'll try to uh, upload that video on the topic. So thank you. Bye bye.